Welcome back. We're going to start a new unit today. This will be our 6th unit of the year, second of the marketing career number 2. This starts through the chapter 10 in our book, and we're going to be looking at some probability stuff and some counting things along the way. So our first targets for this unit, the first part of this lesson, I can use the counting principle to find the number of ways a series of events can occur, and I can evaluate factorial expressions, and I can give the number of permutations of a given situation. Now it's day 1, day 2, that could be the assignments in class. We're going to cover all that material today in this video. Okay, so I have this stuff down. Sorry about that. I'll have this stuff down in your notes so we can be ready for both days. Okay, one way to count things is by making what we call a tree diagram. Just want to show this to you because this is a way that if you get desperate and you can't remember the properties, this is a way to list things out. Before, if you didn't have the algebraic methods that we're going to learn about, this would be the way to do it. So in this question, it says, SpongeBob is getting ready to order breakfast at the Krusty Krab restaurant in the city of Bikini Bottom. He has the following choices: eggs, scrambled, fried, or poached, meat, bacon, sausage, or ham. How many different ways can SpongeBob order breakfast? Okay. So he's going to have eggs and meat. Okay, so we're going to list out the egg choices. He can have scrambled, so we'll put an S. He can have fried, or he can have poached. And these tree diagrams, they can be horizontal or they can be vertical. I'm going to make a horizontal one, but you could easily flip this and make it vertical as well. With each breakfast choice, with egg choice, he can have a meat, a bacon, he can have a sausage, or a ham. And this is true no matter what type of eggs he picks. Sausage, bacon, or ham. Let's switch those two up, that's okay. And bacon, sausage, ham. He has no other choices to make, so what we look at here is 1, 2, 3, 4, 5, 6, 7, 8, 9. So SpongeBob has 9 breakfast choices. You see this a lot too in the real world where they say, this is how many combinations we have. Well, there's 9 combinations here because you can, every time you pick a type of egg, you still have 3 choices for meat or vice versa. If we look at this also, we had 1, 2, 3 types of eggs. We had 1, 2, 3 types of meats. 3 times 3 is 9 as well. That's going to be the counting principle. We're going to see that on the next slide. So as I alluded to here on that last slide, there are some easier ways to kind of come up with these numbers than making a tree diagram. Now last one, it wasn't that hard because there weren't that many choices. As you get more and more multiple choices on each step, it's going to be harder and harder to list those out, more time consuming. Okay, so let's try a couple of examples here and practice the counting principle. The counting principle basically says however many choices you have in each step, and they're independent of each other, you multiply the choices of each step, and that's your number of total choices. Okay, so let's practice that with pizza. You're buying pizza. You have a choice of 3 crusts, 4 cheeses, and 5 meat toppings and 8 vegetable toppings. How many different pizzas with 1 crust, 1 cheese, 1 meat, and 1 vegetable can you choose? So if we're just going to pick 1 from each of those, they're all independent of each other. So what we do is we say, okay, there's 3 crusts times there are 4 cheeses times 5 meat toppings times 8 vegetable toppings. And we just put that in our calculator, and we get 480 total pizzas given those constraints. And we're just going to choose 1 of each. Outfits. You're going to wear something to the meeting. You have 2 pants, 8 shirts, 4 pairs of socks, and 3 pairs of shoes to choose from. How many different outfits can you create? Same thing. 2 pants times 8 shirts times 4 pairs of socks times 3 pairs of shoes. We get 192 outfits. Now we're not talking about whether they all match or not, so don't get carried away here, but that's just that's the number of ways you can combine them together. Okay, telephone numbers. The telephone Time of telephone numbers all begin with a 329 followed by 4 digits. How many different phone numbers are possible if numbers can be repeated and numbers cannot be repeated. Okay, so let's look at that. So basically, we're looking at the last four numbers of an area. It's Westland, whatever city you're in, they all have a combination of numbers. They start with the same three numbers, and then you can have four other numbers after. So these all start with 3, 2, 9, and then they have four numbers after that. So if we can repeat numbers for the first choice, how many numbers do we have? Well, there's 0 through 9. That's 10 numbers. And if I can repeat them, if I say I can get 5, 5, 5, 5, then I have 10 choices for each, or 10,000 total numbers. If I cannot repeat them, well, I still have 10 for my first choice, but whatever number I picked the first time, if I can't repeat it, I have one less. And for my third choice, I have one less than that. And for my fourth choice, I have one less than that. So it's 10 times 9 times 8 times 7, which is 5,040 numbers. So if you're the phone company and you wanted to not have to get a new 3-digit extension very quickly, are you going to allow repetition or not allow repetition? Personally, I would allow repetition because you get almost double the possible phone numbers. So that's the difference between repeated and not being repeated. When you repeat values, you have more possible outcomes, more possible combinations. Here is a problem. It's from your book. These are actual 6 awards are given to each 6 regions. 52 each of the 6 regions. There's 52 countries in Africa. There's 47 countries in Europe, 45 in Asia, 36 in the island nations, 19 in South and Central America, 3 in North America. How many different 6 countries can be represented by the prize winners in a given year? Well, we're going to pick 1 out of 52 for Africa nation. So 52 times 1 out of the 47, or 47 in Europe, times 1 out of the 45 in Asia, times 1 out of the 36 on the island nations, 1 out of 19 in South and Central America, and North America we only have 3 countries, so we multiply those all together, and if we're just drawing it at random, then we have quite a lot of possibilities. 225,678,960 ways to pick a person from each region. Okay, so that first part we did probably be the first half of your lesson, or the first day of your lesson if we break it up into 2 days. This will be the second half of 10.1 of that lesson. We're going to talk about factorial in this section, or this lesson. Factorial is the exclamation point. That means factorial. It doesn't mean yay problem or yay 6, like we're looking at the first one. It means it's factorial. So it's okay, it's factorial. What does factorial mean? It means take the integer that you divide, this is 6 in this case, and multiply it by every integer that is less than it down to 1. We don't go past 1 because if it's 0, that would be a pretty easy problem every time, wouldn't it? So 6 times 5 times 4 times 3 times 2 times 1 is 720 on our calculator. On our calculator, if we hit 6, let's clear this out, 6, and then we hit math, and then we hit probability, PRB. If we see down here, there's lots of things we're going to use out of this list. Number 4, 6 factorial is 720. So on the calculator, the keys we hit once again are the math, and then we hit PRB, and then we hit the number 4 for factorial. Okay? So we can do this in our calculator, we can do it by hand, but that's what factorial means. We're going to see that in some expressions coming up. Permutations. A permutation is going to differ from combinations. We saw that probably in our word wall words, permutation and combination. Maybe discuss that a little bit when we have presentations in class. Permutation, once again, is ordering of n objects taken r at a time. If you're talking about a permutation, you're talking about a situation where it matters what order things are placed in. Excuse me. For instance, a permutation in the sports world would be like a batting lineup. It matters what order you're placed in the batting lineup, because if you bat first, you're going to bat more often than somebody that bats ninth. So order matters for permutations. When you think of a food, ice cream cones. Whatever order you stack ice cream on an ice cream cone, assuming you're not going to dump it out into a bowl later, whatever order you stack it on an ice cream cone, that is a permutation because that's the order you have to eat them in. So permutations is when order matters. There are 6 permutations of the letters A, B, C. How do I know that? Well, 6 permutations of the letter A, B, C. Let's take a look here. Oh, first of all, I forgot to mention the formula. Permutations, n things, choose r, take an r at a time. So the formula for it is n factorial over n minus r factorial. So that's why we're reading about that factorial thing. So 6 permutations of the letter A, B, C. That's 3 things. You pick 3 of them at a time. Or 3 factorial over 3 minus 3 factorial. That's 3 times 2 times 1 over 0 factorial. And here's a little trick. 0 factorial. It's not 0. It's the weirdest thing ever. I think it's just to make it work out when you have these situations. But 0 factorial is actually 1. 0 factorial is 1 every time. Write it down, know it. 6 divided by 1 is just 6. So there are 6 permutations, letter A, B, C. Another way you could do this is you could list them all out, right? A, B, C, A, C, B. And then we could do B, A, C, B, C, A. And we could do C, A, B, and C, B, A. So those are the 6 ways we can order them. Okay? Let's look at another example here. You have 6 homework assignments to complete over the weekend. You only have time to complete 4 of them on Saturday. In how many orders can you complete 4 of the assignments? So if order matters, which one you do first and which one you do last, it's a permutation. We'll talk about what it means when order doesn't matter. So we have it set up here, 6 things. Choose P, choose 4, 6 factorial over 4 factorial. If I really wanted to, I could do this by hand. That would be 6 times 5 times 4 times 3 times 2 times 1 over 2 factorial, which is 2 times 1, right? 6 minus 4 is 2. So if I look at that, and I write it out like that, those would cancel out. So really it's just 6 times 5 times 4 times 3, which is 6 times 5 times 4 times 3 times 8 is 360. So there's 360 ways you can do your homework on the weekend. Cool thing about this is you can do it on the calculator as well. If we go math and we go PRB like we did last time, notice there's an NPR. Oops. And before we hit that, you have to type in your, excuse me, your N value. So 6, math, PRB. We're going to go down to number 2. 6 things, choose 4 of them. I get 360 as well. So we can do this on our calculator. Once again, on your calc, we would pick math, PRB, and this time we would go to number 2, NPR. Okay. Real quick, just to review it, or you can practice at home. If you have 9 chores to complete, how many orders can you complete? 5 of them. Say you're only going to do 5 one day, much like you did with the homework assignments. 9 things, choose 5. On the calculator, we can just do 9, math, PRB, number 2. 9 things, choose 5. We get 15,120 ways to we can do our chores. So the big thing is going to be in this unit, just depending on does order matter or not. Sometimes it's not as easy as it always seems. Okay, permutations with repetition. So what do I mean by this? I mean, how do we count or permutations when things repeat, when there's like the same symbol but it repeats in a word, for instance. Okay? There are three, it says three distinct permutations of the letter I because of the repetition of the letter E. So E, Y, E, 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 Y, and Y, E, E. Now if the letter E didn't repeat, there would be more, because then we could flip-flop these E's, where it's E, E, Y, and the Y, E, E, we could flip-flop those. We could also flip-flop the E's in the word I, first and last. So it would double our number of possible permutations. So is there a way to represent this as a formula? Yes, there is. I know you were just excited to hear that. The formula for that is n factorial over s1 factorial times s2 factorial. This dot, dot, dot means as many as you need until the last term factorial. So basically, what is the s1 and s2? Sn? They're the number of things that repeat and how many times they repeat. So for instance, for I, there are three letters in I, there's 3 factorial. One letter repeats twice. So it's divided by 2 factorial on the bottom. 3 factorial divided by 2 factorial, that's just 3. You do that in your calculator. I'll show you how to do that in the calculator real quick. Actually, let's do alpha y equals, just in case we wanted to, 3 math PRB 4 divided by 2 math PRB 4. Hit enter, and we get 3. So you can do it in your calculator as well. Let's practice with some other words. You can have some homework problems. We're going to do the same thing. Even in California. So if we use the formula, n factorial, there are 1, 2, 3, 4 letters. Only one letter repeats. It's E. It repeats twice. So I get 4 times 3 times 2 times 1 over 2 times 1, which is just 4 times 3, or 12 permutations of the word even. Okay? California. Okay, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters that repeat. Or 10 letters period in a word. A repeats twice. I don't think it repeats any more times, so 2 factorial. And any other letters repeat, looks like I repeats twice. So another 2 factorial. And I don't see any other letters that repeat. So this ends up being 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1, which would be just 4. You could cancel it out that way. Or we could just go to our calculator and we could put it in like this. Which would be 2 factorial times a 2 factorial. It's just 2 really, but we'll go through the whole steps for you. And 10 factorial, which would be, insert a 10 here, delete that 3. We get 10 factorial, which is 907,200 ways to order the letters in California. So, we've met our goal today. I can use the counting principle to find the number of ways a series of events can occur. I can evaluate factorial expressions. We did that. I can find the number of permutations of a given situation. Please have your notes ready for tomorrow in class. Have a good day.